Welcome back. In this second video, we will solve some logarithmic equations. So here we're in exponent form, but it's going to be easier to solve in log form. So we're going to change it to log. We have a base of 17 and an argument of 56, and that equals the exponent, which is negative 9 plus 4x. Now, in order to evaluate this, I'm going to use the change of base formula, putting it into common log. I've got log of the argument divided by log of the base. Now, in this same step, I'm just going to go ahead and move this negative 9 over here, and it's going to become plus 9 equals 4x. Then to get x by itself, I will have to divide both sides by 4 to cancel that out, and now I can just type all of this in my calculator. So I have log 56 divided by log 17 plus 9, and I'll hit enter right here, and then divide by 4, and I have 2.6052. My next equation, I have log base 7 on both sides, and if I do base 7 on both sides, that'll cancel out my logarithms. So I have 2x minus 8 equals negative 5x. Now if I subtract that 2x onto the other side, I've got negative 8 equals negative 7x. And if I divide by negative 7, I get x by itself, and x equals 8 over 7. Now, if I plug that back in here, 2 times 8 sevenths, that's 16 sevenths, a little bit more than 2, minus 8, I'm going to get a negative argument. And negative 5 times positive 8 sevenths will also give me a negative argument. So this solution is not going to be valid. So I'm going to have to say that there is no real solution to this equation. Our next equation, 2 times e to the x minus 1 equals 11. I'm going to add this 1 and get 2 times e to the x equals 12. Then I'm going to divide by 2 and get e to the x equals 6. Now that I have e to the x by itself, I can cancel out that e with a natural log on both sides. So natural log cancels out, and I get x equals natural log 6. And in my calculator, I can do natural log 6 and get 1.7918. Here I'm going to subtract the 3, so I get 5e to the x equals 15. I'll divide both sides by 5 and get e to the x equals 3, and then natural log on both sides cancels out the e, so x equals natural log 3, 1.0986. Next equation, natural log x plus 3 equals 1. If I do base e on both sides, I will cancel out that natural log, and I get x plus 3 equals e to the first power, or just e. And then I can subtract 3 from both sides and get x equals e minus 3. So in my calculator, e to the first power minus 3 is negative 0.2817. If I plug this back into the argument, negative 0.2817 plus 3, I will get a positive argument, so I know I can keep that solution. So here I have 2 natural logs, and I need to condense this side before I can cancel out the natural logs. So that's natural log, and we're adding them, so we're going to multiply the arguments. X times 2x equals 2. Now I can do base e on both sides to cancel out that natural log, and I get 2x squared equals e to the second power. Then I can divide by 2, so I get x squared equals e squared over 2. And then a square root will cancel out this squared, and I'm going to get plus or minus. So I have the square root of e squared over 2. And that's plus or minus 1.9221. If I plug the positive version in for x, I'll get 2 positive arguments, but if I plug in the negative version, I will get 2 negative arguments. So x equals 1.9221, but I have to throw out that negative solution. On our next equation, we have 2 logarithms that need to be condensed. So we're going to have log, and it's log base 10, or common log. And because we are subtracting these 2 logarithms, that means we are going to be dividing the arguments for x over x plus 1 equals log 4. Now, if I do a base 10 on both sides, because that's a common log or log base 10, that will cancel out my logarithms. And I've got 4x over x plus 1 equals 4. It's very tempting to cancel these x's, but I cannot do that unless I can cancel this x out of this term, and this term, but I can't, so there will be no canceling here. So we're going to take this x plus 1 and multiply it over here, and it's canceled there. So we've got 4x equals 4x plus 4. And I can subtract this 4x from both sides, and I'm going to get 0 equals 4. But 0 does not equal 4, so that means there is no real solution to this equation. And next we're going to have to condense again. So we've got log base 10, or common log, and this time we're adding, which means we're going to multiply these arguments. So that's 4 times x plus 1 equals 1. So it's base 10, which means if I do base 10 on both sides, the logs will cancel. And I get 4x plus 4 equals 10 to the first power, which is 10. Then I can subtract 4, and I get 4x equals 6. And divide by 4 and get x equals 3 halves. Now, if I plug 3 halves in for x, 3 halves plus 1, that's going to be a positive number, so that means this solution is valid. In our third video for this review, we will graph some logarithms.